one. Stay with me, do not fall behind. So we'll start with a simple review. Read it with me. So today is basically a review. Okay, we're wrapping up the lecture, wrapping up the lesson. So it says if v of t equals t squared minus t, denotes the velocity of the object in meters per second, find the total distance traveled over the interval 0 to 2. Okay. So we'll start by writing distance. Okay, we learned distance this week. Do not speak. I'm giving you 3 in time. What's the definition of distance? What's the formula for distance? Okay, Mr. Gurbani.
It's the absolute value of the function.
It's the absolute value of what?
It's going to be 0 to 2 v of t. Absolute value v of t.
It's integral 0 to 2 absolute value of v of t dt. Okay, you need to memorize it. You don't have an option. Okay, can we plug it in?
Yes.
So is that t square minus 2 absolute value? Okay, we learned this last time.
Fine.
Who remembers how we integrate an absolute value function?
Find the x
Intercept.
Thank you. They smartly say find the x-intercept. So you find the x-intercept.
Factor out of t.
So it's t minus
t and
0.
0 and 1.
0 and 1. And we use one.
Stop. Let me do the questioning. So which is the relevant x-intercept?
1.
1.
1. So should we break up the integral?
Yes.
Yes.
So it's 0 to 1 t square minus t.
And absolute value of the output.
Value.
Okay, some people are me now. So we take absolute value of this because I don't know if this is positive or negative, plus absolute value integral from
1 to
1
0.
and 2.
2.
t square minus t
Minus t.
dt. Oh, sorry, dt inside. Okay. Absolute value. Is that clear?
Yes.
And then I'll just do the first one. For practice purposes. Absolute value. So begin by writing absolute value. Integral of t square
T cubed over 3.
3.
minus
T squared
Minus
over
2
3.
Minus
divided
t
by
is
2.
0 over 2.
Lower
0 limit 1
0 to 1
plus
absolute value plus
absolute value. Is the integral exactly the same? So we can accelerate a little bit.
Mhm.
Look down. To be faster. And that's 1 to 2, correct?
yeah.
Yes.
Actually, let's just go ahead and do it. Okay, let's just go ahead and do it. They're not bad. Is that 1/3 minus 1
Yes.
minus 0, correct?
Yes.
Plus 8/3 minus 4/2
Yes.
2.
yes.
minus parentheses 1/3 minus 1/2.
Yes.
Yes.
Okay, for 1/3 and 1/2, should we take LCMs?
Yes.
Yes.
That's 6. So
Over 6 minus 3 over
2, 3, 3.
1 over 6.
So is that
Negative.
negative 1 over 6?
Which is 1 over 6.
Yeah.
Okay, but I'm showing. So that's the guy that was negative. Is that clear? That was under the curve. That was under the axis. And then over here, let's do mental math. What's 8/3? Take away 1/3.
7/3.
7/3.
Okay, watch your signs. Be alert. Watch your signs. What's negative 4/2?
Negative 3/2. Oh.
Negative
Not
5.
1/2?
Negative 5
Negative
halves.
3/2.
Negative.
Negative.
3 halves. It's negative 3 halves.
Negative 3/2.
Okay, and then 2 there, LCM again. 3 there, 3 there.
Yes.
So, as Ms. Chawla said, that's 1/6. And what's 14 take away 6?
8.
Sorry, 14 take away 9. 14 take away 9.
5. 5 over 6.
5.
Is that 5, 6? And positive, correct?
Equals 1.
Final answer
1.
1.
1.
This was 5, 6. Absolute value will stay 5, 6. Final answer. Okay, so I want you to observe the process. The process is you break up the integral at the relevant x-intercept. So your first step is always finding the x-intercept. Is that clear?
Yes.
And then add up the integrals. Okay, we're learning something. I mean, it's not brand new, but it's kind of an important idea. Right on page 2, please. This is page 2. So it says definite integral of a rate in function. Okay, you may write down the topic. I want to show you a concept. If I have a of t, okay, and I take its derivative, which is a dash of t, will I get r of t basically?
Yes.
Is that the rate function?
Mm-hmm.
This is not tricky stuff. This is kind of like obvious. Yeah, I get it. If I take its derivative, I'll get the rate function. Yes?
Yes.
So if I go backwards, so if I'm given the rate function and I go backwards will be, don't speak yet. If I go backwards, am I finding the integral or the derivative? Am I going backwards?
Integral.
Integral. So if I integrate r of t, should I get backwards amount function? Is that
Yes.
kind of intuitive?
Yes.
So in other words, if I were to integrate, say 0 to t, r of t dt, will that give you the amount function?
Yes.
Is that kind of intuitive?
Yes.
Yes.
I'm making a general concept. It's an important idea that if you integrate the rate function, it should give you the amount function. Is that kind of obvious?
Yes.
Yes.
Okay, now, therefore, assume for a second you have a rate in function. So write this down, please. You have a rate in function. Assume I call it f of t. Okay, that's like Ri, rate in function. I'm going to say something, see if it makes intuitive sense. So if I integrate, say 0 to t, f of t dt. Remember, I'm integrating the rate in function. Will that give you the amount in function?
Yes.
How much came in? How much came in? How much arrived? How much was deposited? It'll give you the total amount in. Does that make sense? So in today's lecture, so I'm letting you know, today's lecture, there'll be times throughout the lecture where I'll need the amount in or amount out. And I want you guys to scream, oh, just integrate the rate in or integrate the rate out. Is that clear? That'll give you the amount in or amount out. Likewise, go down. It says definite integral of the rate out function. So assume for a second, I have a rate out function. Because remember, if you integrate the rate, you'll get the amount. I have a rate out function. Assume for a second, we call it g of t dt. I'm just making it up. That's actually the rate out. So you guys feel free to call out. So if I integrate the rate out function, that will give you
Amount.
amount out. So the total amount that left, correct?
Yes.
Mm-hmm.
Okay. When I say amount out, I mean like how much did left. Is that clear? What is the total amount that left? So I want you to observe that process. This is not something you memorize. See if it's very intuitive. Because if I take the derivative of amount, I get the rate. So if I take integral of the rate, I can get the amount. See if that's intuitive. Yes?
Yes.
Okay, now let's do some problems. Write on page 3, please. There's nothing for you to sketch or write. Just play along. Read the question with me, please. Read the question with me. Okay? Is Mr. Manastra here? Yeah, he's there. Okay,
Yes.
Everybody read the question with me. It says, a snowstorm
Deposits.
deposits. So is that an in or an out?
In.
In. Observe the context. A snowstorm deposits snow in a valley at the rate of s of t. So is that the rate function? Yes.
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 Is that kind of the rate in function?
Rate in. Yes.
Is everybody okay there? It says rate of s of t and deposit. So that's rate in function. So make a note. So rate in is basically s of t. Is everybody okay there? Measured in pounds per day. Okay. Write that down. Depicted by the graph below. Okay. And the question says, how much snow was deposited in the valley over a month? A month is how many days?
30.
30, 31.
31.
Does the number make sense from the graph?
Mm-hmm.
Okay, so it says how much snow. So what do they want?
A of 30.
Do they want amount in?
Yes.
Yes.
Does that make intuitive sense? How much snow was deposited in the valley? So we want amount in, correct? So just write amount in equals amount in of t, or just amount in over 30, correct?
Yes.
Equals, I'm going to write something on the board, see if you're intuitive, saying, yeah, I get it. Is that integral from 0 to 30 of s of t dt?
Yes.
Yes?
Yes.
Correct? If I integrate the rate in, I'll get the amount in. And, oh, by the way, what's the shape of that graph?
A trapezoid.
A trapezoid.
Let's actually do this. What's the formula for area of a trapezoid?
The
Average.
The average of the
average of
parallel
the parallel
sides
sides
Average of the
times the
parallel
distance.
Parallel side.
30,000 plus
Plus 10,000
10,000.
10,000
divided by 2
Divided by 2.
times
divided by 2 times distance between the parallel
30.
sides. Is that 30?
30.
Yeah.
Let's do mental math. What's 30,000 plus 10,000?
40,000.
40,000.
What's half of 40,000?
20,000.
20,000.
Times 30, is that 600,000?
Yeah.
Yes.
What would your units be? It says how much snow?
Pounds.
Pounds.
That's the amount. That wasn't too bad, was it?
No,
No.
not too bad.
So once again, before we leave, but leave as in this question, please observe this idea. If I integrate the rate, I'll get an amount. If it's rate in, it'll give you amount in. If it's rate out, it'll give you amount out. Is everybody okay with that idea? I'm going to use it over and over and over again. So if I say, guys, what do I need? You'll say, oh, I need amount in. Or you'll say, oh, I need amount out. So I'll say, how do you do it? And you'll say, oh, integrate the rate out or integrate the rate in. Okay, let's do another problem. Right now, look at page 4, please. Right on page 4. Read it with me. It says, after a carnival, people are
Leaving.
Leaving. Rate out.
leaving at a rate of RP. So what are they really giving you?
The rate out.
Rate out, keep that in mind. Keep that in mind. Measured in people per minute, depicted by the graph below. At time t minutes, what is the total number of people that left the park over the first 6 minutes? So what are they asking?
The amount out.
I love you, Nogani. Do we want amount out?
Mm-hmm.
And what have they given us?
6 minutes.
The rate out.
What have they given us?
Oh,
Given us rate out.
Right.
So what does you get?
The integral of the rate out function.
Thank you. Let me just find, it says first 6 minutes. So amount out at 6 minutes is that integral from 0 to 6 of rate out dt. Everybody okay there?
Yes.
Can we move on? You guys got the hang of this?
Yes.
Yeah, everybody. Actually, let's quickly do this. It's at 6. Okay, let's actually do this.
Okay.
Okay. Is that a trapezoid also?
Yes.
Okay.
Mhm.
What are the parallel sides?
6 plus 2.
Thank you. So 6 plus 2, write this down. 6 plus 2 over 2. What's the distance between the parallel sides?
4.
4.
Simplify in your head. Tell me what you do.
16.
16.
16.
Okay.
And then is that next guy a rectangle? What's the base of the rectangle?
2.
2.
What's the height of the rectangle?
4.
Two.
2. So
4. So final answer,
20.
20. Is everybody okay there? Oh, will the units just be people? It says how many people left.
Rama,
Yes, go on.
can you think of it as like there's a mismatch, so you could do a dash of the amount?
No, you're right. But it's an important idea for you to observe. If I have rate out, I
yeah.
understand what you're saying, but it's an important idea for you to observe. If I have a rate out, I integrate, I'll get amount out. If I have a rate in, I integrate, I'll get amount in.
Yeah, it makes sense. Thank you.
Okay. Right on page 5. Everybody over on page 5. Okay, read it with me. After a carnival, people are leaving at a park at the rate of r of t dt. If there are 120 people at the park at the end of the carnival, so what are they giving you there?
A
Total.
of 0?
Thank you. Are they giving us the a of 0? The
Yes.
initial amount, okay, at the end of the carnival. So write down a of 0 equals 120. Is everybody okay there?
Mm-hmm.
Now the question is, how many people were in the park at the end of 10 minutes?
Amount.
So
8 of
should we use
net change corollary.
net change corollary? So a of 10 equals
A of 0.
a of 0.
0 plus
0, 0 to
Integral
10.
to 0 to 10.
a dash of
What's missing? A of 0,
plus
integral
Integral
0
from 0 to 10.
0 to 10,
A dash.
basically r
A
of
dash.
t.
Uh,
Okay, a dash should use r of t dt. Okay, nobody speaks. Oh, and then a of 0 is 120, correct?
yes.
Yes.
Okay, let's see who is insanely smart. Do not speak. This is incorrect.
Because
Take
it's
the ball
rate,
and run.
because it's only rate, so you have to put rate out. Or-
No, we're fine. It's a read out, it's fine. Observe the context of the problem. Hint, this is rate out. So when you integrate, what will this give you?
Oh, the amount out and it's
Amount out.
and it's asking how
So how should I change? We began with 120 people. And we
A
have
minus?
minus. Does that make sense? Okay,
Yes.
right. That should be a minus sign
Oh.
because there are no people entering. There are only people leaving. Does that make sense? This is an out function. Very good, Mr. Nagani. He looked at the context of the problem. It wasn't a trick question. It had to do with, hey, people are leaving. Everybody, look at the board. If you do plus, aren't you saying people are entering the park?
Yes.
Does that make sense? So please look at the context of the problem. If people are entering the park, the plus makes sense because this gives you the accumulation. How many people in general have added up? But we want how many people are added up that were leaving. So we have to subtract that. Is that clear?
Yes.
Okay, I'm accepting clarifications or questions saying, okay, I'm lost. I don't know why we did minus. Remember, we began with 120 people at the end of the carnival. People are leaving. Should we not subtract them, not add them? Everybody okay there? So you're learning so the context of the problem makes sense. Okay, you need to be alert to the context of the problem. Okay, the rest of it is easy. You can integrate easily.
Yes.
Okay, let's move on. Okay, now we have done a whole bunch of word problems using a calculator. I want to show you word problems where we can do them by hand. Okay, that's today's homework. Okay, you'll get homework questions where you have to do all the math by hand. Relax, the algebra is easy. Okay, stay with me right on page 6, please. Stay with me. We're on page 6. Relax, it's an easy problem. Don't freak out. Okay, it says at an all-day convention, attendees are
Entering.
entering a hall at a
Rate.
rate of I of x. Oh, that should be I of t. Sorry. Make it I of t. All these should be t. Okay, I of t. Whereas attendees are leaving the hall at a rate of,
Oh,
all right, both rates measured in hundreds per hour. So write down I of t in your notebook, O of t in your notebook. And the scale is hundreds per hour. Write that down.
Mm-hmm.
And it says when the convention begins, there are 1,000 attendees in the hall. So I'm going to set it up the usual way. How do we always set up rate and rate out problems?
is
Let
amount
A be the
of attendees
Amount of
amount of
in the hall.
attendees
In the hall. At time t
T.
at time
in
t
hundreds.
in hundreds. Very smart. She writes in hundreds. Okay, in your notebook, we're learning a new idea. It's a scale of hundreds. Underline that. Okay, and then A dash of t is
Rate of r t
R of t,
is I of t minus
I of t minus in minus out. Everybody okay there?
rate of change
Yes.
It's
of
the rate
the
of change.
of the amount of attendees in the hall at time t 100 per hour.
The change of the amount of attendees or number of attendees in the hall at time t. Don't be lazy, please. Oops. Okay, in hundreds per hour.
Yes.
Yes.
Okay. Okay. Now I'm going to write something incorrect. I want you again. You're learning new skills. Ms. Shyamalan, you're learning new skills. I'm going to make a mistake. See if you're smart and point out my mistake. And then it says when the convention begins, there are 1,000 attendees in the hall. Okay. I'm making a mistake. Stop. Do not speak. Give it thinking time. Then give it about 10-15 seconds. Then point out the mistake I made. Okay, go. I'm accepting suggestions. I just wrote something that is incorrect.
The units is 100,
100,000?
so you have to multiply by 100. So
100,000.
100,000.
No, but it says there are 1,000 attendees. You're making it 100,000.
Oh, wait.
So
Zero equals
if it's no, let me clarify. So if it's in thousand, so if our scale is hundreds, 1,000 should really be written as
10?
10
10.
hundreds.
Thank you. That's actually 10 in hundreds, correct? You have to be consistent. Not 1,000 hundreds, but there are only 1,000 attendees. If you write 1,000 in hundreds, that's like we have 100,000, but we don't have 100,000 people. Am I making sense? 1,000 is actually 10 hundreds. Is everybody okay there? You have to be consistent in our scale. Okay, now it says how many attendees enter the convention hall on the first 8 hours? Guys, we want, what is the question asking for? It says, how many attendees enter the hall?
Amount.
The amount in.
Amount in. Okay, you're being alert. How do we always find the amount in function? We should simply
Integral
integrate the
0 to 8
The rate
of
in
which
function.
function?
R.
I of t.
I of t. Pay attention, please. It says enter. Observe the. So you learn things new today. You have to look at the language. It says how many attendees enter the hall, convention hall. Is that I of t dt? Is everybody okay with that? Remember, if you integrate the rate, it'll give you the amount function. Okay, let's do that. 0 to 8, and that guy was 1/2 e plus 1 to the power of 3 over 2 dt. Do not freak out. We're just going to use the power rule. Stay with me. Do not fall behind. So 1/2. So we're going to use the power. Is that clear? So it becomes, put a space. E plus 1 to the power of
5 over 2.
5 over
and
2.
5 over 2.
5 over 2 times
2.
2 over 5.
be
2 over 5.
careful. And then times 1 because the slope is just 1. Lower limit,
0.
upper limit,
8.
8. Will the 2's cancel?
Yes.
Is that 1/5? T plus 1 to the power of 5 halves. Actually, let's accelerate. Okay. What's 8 plus 1?
9.
9.
To the power of 5 halves. Yes.
Mhm.
Minus 1/5. What's 0 plus 1?
1.
Power of 5 halves. Yes. Now this can be done by hand. Don't freak out. This can be done by hand. Okay. What's the square root of 9?
3.
Now I'm doing this in my head. Now 3 to the power of 5 is 243.
Yeah.
So 243 over 5 minus 1 over 5. Yes, because 1 to the power of anything is 1. So final answer
243.
over 5.
People?
Careful.
Oh, 100.
Hundreds.
In hundreds.
Hundreds. In hundreds. Exactly. Yeah. Okay. Before we move on, I want you to look at the problem once again. It didn't say how many attendees are in the hall. It said how many attendees enter the convention hall. Is that clear? And Mr. Bilaramino and Mr. Nagani said, oh, just integrate the in function. The rate in function will give you the amount. Okay, we're tying up concepts. We're tying up concepts. Okay, go to page 7, please. Please be alert to the language. Please be alert to the language. Okay, read the question from here. Do this with me. It says, read it with me, please. Read it with me, please. It says, is the number of attendees in the convention increasing or decreasing at t equal to 3? From the first semester, if a function is increasing or decreasing,
It's slow.
it's slow, positive or negative, correct? Now remember, the number of attendees is just A. So what do we need to find?
A of 3.
A dash, correct? If we want to find its increase or decreasing, we need to find its derivative. Is that A dash of 3?
Yes.
Yes.
Everybody okay there? Oh, from earlier, wasn't A dash of t nothing but I of t minus O of t?
Uh-huh.
Yes.
Can we just plug it in there? Is that just I of 3 minus O of 3? Is everybody okay there? Okay, let's slow down and go over it again. It just says, is the number of attendees increasing or decreasing? From the first semester, remember, number, amount, population, volume, they're all amounts. So if our amount is increasing, we do just do A dash. Okay, let's plug in I of 3, which is 1/2. What's 3 plus 1?
4.
4.
To the power of 3 halves. Minus, is O of 3 just 4?
Yes.
Yes, it's a constant, right? That's a constant. Okay, let's do this. Look down, please. I'm walking you through it. What's the square root of 4?
2.
2.
Cubit.
8.
8.
So is that 8 halves?
0.
4.
Ooh.
0.
Okay, this is a weird problem. 4 minus 4. Okay, no, it's fine. 0. So do we write increasing or decreasing? Or neither?
Neither.
Neither. Is that clear?
Yeah.
So just say at t equal to 3, the number of attendees, get it from the question, is neither increasing nor decreasing. Since A dash of 3 is,
Equal to 0.
okay? I'm tying up concepts from the first semester. But the big idea you're learning is if you integrate the rate, you'll get the amount. If you integrate rate in, it'll give you amount in. If you integrate rate out, it'll give you amount out. Okay, go to page 8, please. Actually, we'll skip this. Go to page 9, please. I'm sorry, right on page 9. Okay, do not speak. I'm giving you time to experiment, blunder, make a mistake, and pick yourself up. Do not speak. I'm underlining. Write something down. I'm showing you language. Observe the language, please. Observe the language, please. Okay, Mr. Trees or Mr. Smith, what is the question asking for? It says, how many attendees leave the hall over the interval 0 to 6? So what is the question really asking for? Mr.
Amount
Trees
out?
or... Sorry, say that again.
Amount out?
Love you. Amount out of 6. Okay, what is the concept, Mr. Trees or Mr. Smith? How do we find that?
The integral of
Which
the rate.
one? No,
Well,
but which?
IX,
No, well, which rate?
rate at which attendees are leaving the hall.
Thank you. Is that O of T?
Yes.
Is everybody okay with that idea? Did most of you figure it out? Okay, if you integrate the rate, you'll get the amount. Okay, let's do that. 0 to 6, this is stupidly simple. What's the integral of 4?
40.
40,
Lower limit 0, upper limit 6. What's your final answer?
24.
24.
Half full?
In hundreds.
In hundreds. Love you. 24 in hundreds. That's 2,400 people. This is the amount. Everything scale is hundreds. Be alive. It's there in your homework. Don't freak out. It's there in your homework. So I'll give you practice. Okay. Go to page 9, please. Is that page 9? Where are we?
Page 10.
Yes.
Why is the page number not showing now? Is this page 9?
That's page 10.
10.
It's page 10? Okay, thank you. I don't know. For some reason, the page is not showing up in my document. Okay, let's move on, please. It says, read it with me. It says, find the maximum and minimum number of attendees in the conventional over 0 to 15. How do we always do this problem?
Absolute maximum.
Thank you. Absolute max and absolute min. So write that down. So we want the absolute max and absolute min of the A of T function. Yes?
Yes.
Yes.
So we should consider
Endpoints and critical points.
mimic me. So consider the endpoints and critical points of the A of T function. What are your endpoints?
0.
0 to 15.
Okay. How do we always find the critical point?
A dash. It's
Absolute.
A dash of T, which is nothing but
R.
R of T, which is I of T minus O of T. I should set it
Equal
equal
to
to 0.
0.
Technically, 0 does not exist, but 0 most of the time. Okay, let's do that. Okay, it'll be there on your homework. So 1/2 T plus 1 to the power of 3 halves minus 4 equal to 0. Yes?
Yes.
Okay, I'm showing you how to do this. Everybody, observe this. I will isolate this radical. Okay, I'll isolate this. Should I add the 4?
Yes.
Yes.
This is from IM3. This is from IM3. Okay, next step.
Multiply by
Multiply by
Like
2.
Multiply by 2. Very, very good. Basic algebra, guys. Okay, from IM3. Observe the power is 3 halves. Who remembers from IM3? What should I do both powers to get rid of the 3 halves?
Power by
Multiply the
the
power by its reciprocal.
Which is 2/3, correct?
Yes.
So observe the algebra, please. So it becomes T plus 1. Okay, let's do this together. What's the cube root of 8?
2.
2.
Square it.
4.
Final step. Therefore, T equals.
3.
3.
Stop. What do we do with all these values?
Evaluate.
Evaluate. Are we plugging into A of T?
Yes.
Yes.
Okay. Smart kids, now making a connection. We know A of 0 is 10. So what's the formula for A of T? Hint, A of 0 is 10. So A of T equals A of 0 plus
Integral from
Integral.
0 to t.
from 0 to T. A dash of T, which is I of T minus O of T, correct?
Yes.
Is everybody okay with that general idea? Put this in a box. That's the general concept of A of T, correct? We're using net chain in case you're not making that connection. We're using the net chain corollary. And what's A of 0 given to me?
10.
10. Everybody okay there? Now I will just do the first couple of steps and we move on. Okay, and we need a of 0. Even a of 0 already 10, but in hundreds, correct?
Mm-hmm.
But given to be thousands. Okay, what else do we need to find? A of
15
A of 15. Let's do it together. Let's do it together. So what am I writing?
plus integral 0 to 15.
10 plus integral 0 to 15. I'm just plugging it into the formula. And is that basically 1/2 t plus 1 to the power of 3/2 minus 4 dt? Yes?
Mm-hmm.
Let's integrate. 1/2. Actually, didn't we do this earlier? Wasn't that
Yeah.
2/4? T plus 1 to the power of 5/2. Okay, look down. What's the integral of 4?
40.
40.
Lower limit,
0.
upper limit.
15.
15.
Okay, do not freak out. Do not freak out. I'm not doing anything clever. I'm just doing it by hand. Usually we do it on a calculator. Does everybody understand that? Usually we do it on a calculator. I'm saying no, we can do it by hand. Okay, so 10 plus, remember the 2's cancel. 1/5. What's 15 plus 1?
16.
16. What's the, I'm skipping a step. Guys, I'm skipping a step. 15 plus 1 is 16. What's the square root of 16?
4.
4.
4, and that's 4 to the power of 5, correct?
Mhm.
Okay. Minus, what's 4 times 15?
Negative 60.
Negative 60 minus parentheses 1/5. I hope you're with me. What's 0 plus 1?
1.
What's 1 to the power of anything?
1.
1.
1. Is that minus 0?
Yes.
Everybody okay there? Final step. That's 10 plus. Now 4 to the power of 5 is 256. Okay, I'm doing this in my head. So 256 over 15 minus 60 minus 1 over 5, correct?
Yes.
Yes.
Okay. Now at this stage, everybody, at this stage, I'm okay. I'm okay at this stage if you use Desmos to type that in. But your final answer will be in
100.
hundreds. Thank you. Will that be in hundreds? So I was just showing you how to evaluate the interval. Is everybody okay there? And then last step. So we did A of 0, we did A of 15, which is the final guy we need to plug in.
A of 3.
A of 3, very smart. And then can you write a conclusion? Okay, I'm not going to do this. Just make a note to yourselves. We will also evaluate A of 3, and then you write a conclusion. It's my job to show you. So the only reason this was a brand new problem is usually we do this on a calculator. And I'm saying, no, we could do this theoretically speaking by hand also. They gave us weird functions, we use a calculator. They gave us a simple function, we did this by hand. You'll get a much easier problem for homework. Okay, before I move on, I'm accepting suggestions, questions, clarifications. Nothing clever. Absolute max, consider endpoints, critical points, evaluate the function. That's all we did. That's all we did. Okay. All right, let's move on. Go to page 11, please. Okay, I want you to write this question. I want you to write this on your notebooks. Again, I want you to have this on your notebooks. Okay, now I want you to read this. Okay, do not speak, interpret it literally, do not speak. Is this an average problem or an average rate of change problem? Do not speak. Look at that wording. And guys, you must interpret literally. It should match up with what our interpretations are. Repeat, is this an average problem or an average rate of change problem?
Average.
Okay, I'm accepting suggestions.
Average.
Only average. Can you see it does not say average rate of change? Is everybody okay there? It does not say average rate of change. So it becomes an average problem. Is everybody okay there?
Yes.
The reason it's confusing is it says average and rate. And you're saying, wait a second, this is average rate of change. It's not. It does not say average rate of change. So it's only an average problem. Everybody okay there? How do we always do average problems?
AV.
AV.
Equals 1 over
1 over 5.
Integral.
Integral
0 to 5.
Stop.
Over.
It says the rate at which people leave the hall. So which function do we need?
O of
Oh, T. Exactly. Okay, interpret the question literally. Now, today, to be nice, I will actually italicize the word. So, in other words, today I will actually underline this. I'll underline this. So you say, "Oh, I have to be careful with the language." Okay, is that easy to integrate?
Yes.
0 to 5, 4. DD. Can we move on?
Yes.
Uh-huh.
You observe the challenge was interpreting the question correctly. Like, am I interpreting this correctly?
Yes.
Okay. So we got done with a huge rate and waiter problem. If you are responsible and attend office hours, I'll do more examples like this. But that's on you. If you say, man, I think I would like to see these questions again. So I would strongly encourage you to attend office hours. The test is next week, guys. The test is next week. Okay. Let's do some Riemann sums. Right on page 12. Okay. Read it with me. It says if f of x is increasing and concave down over the interval a to b, arrange the following increasing order: a left Riemann sum, a right Riemann sum, a trapezoidal Riemann sum, and the actual area. Okay. So in your notebook, you can say f of x increasing concave down. So let's sketch a figure. Okay. I'm going to sketch a figure. It should be increasing and concave down. So for those of you who have forgotten how the graph looks, if it's concave down, is it cup up or cup down?
Cup down.
Is it a cup facing downwards? But it's increasing. I'm going to sketch it for you. Look at the board and say, yeah, I get it. It should be rising and cup down. Actually, give it a shot. See if you can graph it yourself. Just make a small curve. It should be rising and facing downwards. What should the graph look like? Use common sense. Don't overthink it. Just make a short segment. Just a very short graph. Let me give you options. Will that work?
No.
No.
Because it's falling and concave down. Would that work?
No.
No.
That's
No.
concave up and
It's
rising.
concave. Very good. It's cup up. Would that work?
No.
It's falling and cup up. Would that work?
Yes.
Yes.
Okay, check if you had imaginations to draw that graph. Okay, so this is the graph we'll deal with. It's actually, so that's the graph we'll deal with. So use common sense to sketch the figure. So it says increasing and concave down. So it's like that. The question says sketch a left Riemann sum, right Riemann sum, trapezoidal Riemann sum, and then we have the actual area. So first, I'm going to draw a left Riemann sum. Stay with me, do not fall behind. So I'm giving you practice with left Riemann sum. I'm okay if you just draw two rectangles. Stay with me, do not fall behind. So we're going to draw two rectangles. Okay, we discussed this last time. I'm accepting suggestions. Who remembers how we sketch a left Riemann sum?
In the left corner.
Very smart. We go to the left corner and go
Right.
Right.
rightward. Is everybody okay there?
Yeah.
Okay, do the same thing for the others. So again, we have a graph like that. Let's do a right Riemann sum.
Right corner.
It's two rectangles. How do we draw?
Corner and go left.
Go to the right corner and go leftward. Is everybody okay there?
Yeah.
What else do they need?
Trapezoidal.
Trapezoidal.
Draw a Riemann sum. Draw a trapezoid. Is that the easiest one? Just join the vertices. Okay?
Yes.
And then finally, just this guy is the actual area, right? That's the actual area. And the question now says, pay attention to the question. The question says, arrange these areas in increasing order. So I'm shading this for you so the answer becomes obvious. I encourage you to do this.
Underestimate.
Okay, he's going on the right track. Okay? He's going on the right track. So we'll go with the under guy first and the over guy. Okay, which is the smallest of these areas?
LRS.
LRS.
Right.
The LRS, is that obvious? The left Riemann sum is the smallest of these areas.
Yeah.
Which is the next area?
Trapezoidal.
Is it the trapezoidal Riemann sum, the right Riemann sum, or the actual area under the curve? We want to do underestimates first. So left Riemann sum was a severe underestimate. Do we have another underestimate?
Yes.
Thank you.
Trapezoidal?
Trapezoidal Riemann sum. Can you see you're below the curve? Okay, so we're out with this. We're out of this. I hope it's making sense. Okay, which is the area that comes next?
The area, the actual.
Yeah, well,
Thank you. The actual area. It's just like a small puzzle. And then which is the biggest of these areas?
Right.
The right Riemann sum. Is everybody okay there?
Yes.
Okay, before I move on, read the question again and observe what we did and why we did what we did. It gave you instructions. It said increasing and concave down. Arrange the following areas in increasing order. We sketched the figure, label all the areas. We and then we shaded them, and the answer just shows up. The smallest. So Mr. Bellarmino clearly said, oh, that's a real underestimate. So look at the left Riemann sum. That's a really small area. And then trapezoid Riemann sum was slightly underestimated. So we took care of that. The actual area was next, and then the overestimate. Let's do one more for practice. Right on page 13. This time it says f of x is
Increasing.
Increasing. Up.
increasing and concave up. So draw it yourselves.
Looks like an
It should be
exponential.
increasing and facing upwards. So check if your graph kind of looks like this, perhaps.
Mm-hmm.
Yeah? Can we start doing left Riemann sum?
Yes.
Okay, now this looks weird. Is a left Riemann sum, okay, I'll switch to blue so you can see. If you're doing it from the corner. Is a left Riemann sum, the top left, go rightwards, is that like that, basically?
Yes.
If you do it like me, it's okay, don't freak out. Everybody okay there?
Yes.
Okay, now let's go right Riemann sum. Do that yourselves. You don't need to look at the board, guys. Just draw two rectangles. Okay, how do we draw right Riemann sum?
Leftward. I mean, rightward to leftward. And go left.
Go to the right corner, go leftwards. Okay, and you can directly start shading rectangles. And then finally we draw
Or trapezoidal.
Trapezoid.
Riemann sum. That's like that, correct? And then finally, this is the actual area. Okay? All right. So we'll go underestimate, actual area, overestimate. Okay? Which is the smallest of these areas?
Right. I mean, left Riemann.
Okay, this is a trapezoid Riemann sum. This is the actual area, integral a to b f of x.
The left Riemann sum.
The left.
Okay, is the left Riemann sum the smallest of these areas? If anybody's confused, this is the time to tell me. I will not scold you. I will not shame you. Can you see the area of the rectangle? The left Riemann sum is the smallest of these.
LRS.
Okay, which is the next area?
Trapezoidal.
The base, the actual area.
Isn't a trapezoid actually the overestimate? So the actual area should come between, guys, the actual area always comes between the underestimate and overestimate. Is that clear? So the actual area should come in next.
Trapezoidal then RRS.
Okay, and then which is a slight overestimate, which is a serious overestimate.
RRS.
Did everybody understand the difference between these two guys? Okay, because one student was immediately saying trapezoid. No, but trapezoid is above the actual area. Do you see that? The trapezoid area is slightly higher. Okay, if you attend office hours, we'll do two more examples. Okay, let's continue. Right on page 16, please. Guys, I'm going to safely assume most of you got the logic of rate in, rate out, amount in, amount out. So we will just rush and set up the problem. Okay, my object right now is not to do every problem. We'll only set up the problems. Okay, read it with me. We're on page 16. Read it with me. It says a store is selling a certain item at a rate modeled by S of T in hundreds of items per hour over 0 to 6 hours, whereas customers are
Returning.
returning the item at a rate modeled by that in hundreds of items per hour over 3 to 8 hours. And suppose there are, typo, at t equal to 0, there are 400 items in stock. Okay, let's set it up the way we did earlier. We will not write tediously. We will just set, I want to accelerate Ms. Chawla, so I'm going to not write it tediously. So let A of t just be the amount, okay, of items in the store. At time t in hundreds, correct? The scale is hundreds. Okay, then A dash of t is
R of T.
R of t, which is
R of T minus S.
Rate of change.
R of T.
minus S of T.
S of T.
if they're returning. So in is everybody. Do you observe Bellarmino's this thing? If they are returning, that's the in guy, and selling, that's the out guy. Everybody, did you observe? Bellarmino was observant of the context. If you're selling, that's out, correct?
Yes.
If they're returning, that's in, correct?
Mm-hmm.
So he smartly said small r of t minus capital S of t. Small s of t. Okay, in hundreds, correct?
Yes.
And then they're giving us that A of 0 is, if learning happened, A of 0 is
400 surviving.
100. Very smart.
800, yeah.
Is everybody okay so far in the setup? Okay, I want you to get practice. See if you can set up the problem yourselves. I'll switch to red so I can focus your attention. Okay, do not speak. I just want you to set up the problem. It says, how many items were sold over 0 to 6 hours? Give me a left-hand side, give me a right-hand side. How many items were sold over 0 to 6 hours? It's not a trick question. Okay, what is the concept? What are they asking for?
Amount out.
Is that amount out?
How-
Let's see.
Mhm.
And if you're familiar with the idea, if I want amount out, I should integrate
0 to 6.
Zero to six, S of two,
which function?
S of
S
two,
of t?
S
S
of
of dt, the rate out function. Is everybody okay there?
yeah.
Yes.
Yes?
Hmm?
Okay, now you're learning something brand new. Draw a skull here. I'm okay if you write down this question. I'm okay if you write, I encourage you to write down the question. You'll see in a moment why. Okay, now stop. I want all of you students to read that paragraph again and somebody tell me why is this problem slightly different from any of the problems we have done so far. Do not speak. Look at the difference. Like, oh, look at that crazy guy. So it says store is selling hundreds of items over 0 to 6 hours. Customers are returning the item R of T 3 to 8 hours. Why is this problem slightly different from any of the problems we've ever done before?
The intervals are different.
I love you, Ms. Chawla. Can you see the intervals are different?
Mm-hmm.
Did everybody observe that? Relax, relax. That does not complicate our matters. But the only thing that has changed is, can you see when we are calculating the integral, should we kind of split up the integral because they don't overlap? Okay, play along, relax, play along. Okay, the question now says, find the number of items in the store at t equal to 8. So what is my left-hand side? I just need the number of items in the store at t equal to 8. So what do they want?
A of 8.
A of 8. So what do you write? A of 8 equals
A of 0.
A of 0, very good, net change corollary, plus
Plus.
integral, stop. Now we're doing in function. So which is the in function?
R
RT.
to 8.
R of t, and that goes from,
0
Three
to
to
8.
eight.
Oh,
is that 3 to 8?
yes.
Is everybody okay there? And that's R of t, dt, and then minus
Minus.
integral from
0 to 6.
8.
0 to 6, and that's the out function. Which function are we doing?
S15 dt.
Is S of t dt. Did everybody okay there? Put a skull here for good notes. Put a skull as in warning. We split up the integral. Intervals. Usually we would have only one integral, but because the intervals were different, regarding the intervals, we just split up the interval. We get to go. And what was the A of 0 given to me?
4 in
4. Oh, and your final answer should be in hundreds, correct?
Mhm.
Guys, for practice, let's actually do this on Desmos. I want to show you. Let's actually do this on Desmos. I'm in no rush. Let's actually do this. Stay with me. Do not fall behind.
Oh, Fibonacci.
All right. In calculus BC, you learn that weird graph. For those of you who saw the board. Okay. Somebody call out what they gave us again. What was S of t or S of x? No?
S of x is x over
X over
5
5. E.
e to the power of
Slow down, please. You're calling out so fast. Desi style. Okay. X over 5.
e to the power
E to
of 0.2x.
Yes.
Okay. Next. I hope you're doing this with me. R of x was given to me.
Sine, and then in parentheses, x squared divided by 5 plus 2 on the outside.
Everybody okay there? And then good habits, I just suppress them. I don't want to get okay. And then let
R.
R of x. Guys, I think Miss No says no. Does the Desmos get confused between capital and small, or it uses the
I
same
think it's just for E.
just for E? Okay, R of x equals Was that S minus R or R minus X?
R minus
Minus
S.
Okay, small Rx minus S. Everybody okay there? Yeah, that sounds about right. Okay. And then finally, what are we doing? Was it 10 plus or 4 plus? I forget.
4. 4
Okay.
plus
4 plus integral lower limit
3 to 8.
3 to 8.
3 to 8. Which
R
function?
dx.
Dx.
Oh, no. Guys, can you see we're not even interested in that, correct? We're using small r and capital small s only. Okay, which one? R or S?
R of x
R.
dx
R of x dx
minus
Minus
integral
integral
0 to 6
6.
s of x dx.
Write down 5.3516. Repeat 4 decimals. 5.3516.
In hundreds.
I love you. She was alert. She said in hundreds. So write down 5.3516 in hundreds. So I'm going to write something on the board. Look at the board and say, yeah, I get it. Is that basically roughly 535 people? Sorry, 535 items. So what you learned with this problem is splitting the interval if the intervals don't match up. Okay, Miss Chawla was alert. She said, hey, wait a second, the intervals are different. So I can't use one integral, I'll use 2 integrals. But one for the in, one for the out. Okay. All right, right on page 17, please. Observe, guys, you observe the variety of problems. Every problem is slightly different. Okay, right on page 17, please. Okay, read it with me. Everybody, please be with me. Read it with me. It says grain is being added to a granary, which is a storehouse, at a rate of G of T, measured in cubic feet per minute, selected values of which are given in the table below. The grain is then cleaned and loaded onto trucks at a rate of H of T, blah, 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 write that down, measured in cubic feet per minute. Initially, there are 200 cubic feet of grain in the granary. Guys, this is not in hundreds, so this is just regular. There's no scale problem. Okay, let's just set it up the usual way. Let A of T be the
amount.
amount of grain in the granary. At time T. And then A dash of T is R of T, which is
H of G of
is that G of T, add to the granary, so that's in, and then clean and loaded onto trucks. Is that out?
yes, 50.
Is everybody okay there?
Mm-hmm.
Okay. Measured in cubic feet per minute. Okay. A of T is measured in cubic feet. Is everybody okay so far?
Yes.
Okay. Oh, and then A of 0 is 200, yes?
Yeah.
Of grain in the granary. Okay, for some reason I didn't even put a question. Okay, I'm going to move on. Right on page 18. Oh, what? Oh, there it is. There it is. Okay. It says use a right Riemann sum with 4 intervals to estimate the total amount of grain added to the granary over 0 to 8. So what are they asking for?
Amount in
Amount in. So what will give you amount in?
the integral of
Integral of
G of T.
is the integral of which function?
G of T.
The rate in?
The rate in function. Everybody okay there? So we want the amount in function at, was it 8? Is that the integral from 0 to 8 of G of T dt? Is everybody okay there?
Yes.
Please master that idea. If you integrate the rate in, it gives you amount in. If you integrate rate out, it'll give you amount out. Okay, and they say use a right Riemann sum. So tell me what to write. Hint, we're doing a right Riemann sum, 0 to 8. Go.
1 times
Times.
15.1
Very good. Plus, what's your second base?
4 times
4
20
Times
20.5
and
plus 1
1 times
times
18.3
3.
plus
plus 2 times 22.7.
22.7. Guys, this is the amount of grain that was added. So what are your units just?
Cubic feet.
Just
Just cubic feet. This is the amount. in. So please understand that idea really, really well. It says how much grain was added. Okay, I'm tying up a concept. I'm doing a ream answer. Okay, next we're on page 19, please. Okay, interpret the question literally. Repeat. Interpret the question literally. Do not speak. It's not a trick question. Do not overthink it. Just interpret what they're asking for. Okay, Ms. Madhya, what are they asking for?
Is it A of 8?
That's it. Do not overthink it. Oh, what's A of 8 equal to?
A of 0?
A of 0. Please be alive. You should be alive to do next corollary always. Plus, interval
Interval 0 to 8.
0 to 8. Guys, the intervals are perfectly fine. They match up. There's no difference. 0 to 8, 8 of t, which is R of t. Yes?
Yes.
Yes.
Everybody okay there? Now, stop. What is R of t after all?
G of T
G of T minus H of T.
Minus
H of T.
Now I'm blowing your mind. Look at the board, please. Isn't G of t the table question?
Yes.
Isn't H of t actually a formula?
Yes.
Yes.
I'm going to say something profound. Think about it and say, yeah, I totally get it. So should I?
Split up the interval?
Should I split up the integral? Because there are two different ideas. So A of 0 is 200. She got the hang of it. So integral 0 to 8 of G of t dt. Wait a second. Did we not just find it? Did we not just find it?
Yes.
Minus integral 0 to 8 H of t dt. Will Desmos take care of that guy? Is everybody okay there? Okay. Now, in your guys, on your homework, I'm informing you, please. In your homework, this calculation, everybody look at the board. On your homework, this calculation is easy. I want you to do this by hand. This one you will do on Desmos, and I want you to give me a final answer. Okay, I want you to give me a final answer. So did everybody observe? I'm kind of playing with your minds. Part of the function was a table. The second part of the function was of a regular function. So we just split up the integral and we get to go. Okay. So keep in mind, this is just Ms. Madhya did not overthink it. She just said, okay, amount of grain at 8. Okay, that's just A of 8 then. Nothing clever. Okay, let's move on. We're on page 20, please. Read it with me. We're on page 20. Okay, interpret the question yourselves. I'm giving you practice. Literally, do not overthink it. It says at t equal to 6 is the amount of grain in the granary increasing or decreasing. So do I need to find? Do not speak. Do not speak. Like this is what I'll find. Mr. Manasra or Mr. Al-Nabulsi, either of you. How do we interpret the question? What do we need? Mr. Manasra or Mr. Al-Nabulsi?
A dash of t.
No, equal to 6.
Oh yeah, a dash of 6
That's
greater
it.
than or equal to 0.
Yeah, thank you. You got that. Isn't A dash of 6 nothing but R of 6?
Yes, which is G of 6 minus H of
It is
6
G of 6
minus
minus H of 6. Yes?
greater than or less than 0.
Okay. Is G of 6, guys, is G of 6 just a table? So what's G of 6?
18.3.
18.3. Minus H of 6. Okay, now stop. Take 30 seconds. Go to Desmos and find H of 6. Okay, take 30 seconds. I have time. I'm in no rush. Do not freak out. And just take the ball and run. I need H of 6. We know H of t. There's no integration involved. So plug in H of x in row 1 and just type H of 6. Tell me what you actually do it. I'm giving you time.
13,
Sorry, go.
13.612.
112
13.6120.
6120. Okay, just by looking at these numbers, will that be a positive number or a negative number?
A positive.
Positive.
So,
So to answer the question, is the amount of grain increasing or decreasing?
Increasing.
Take a note. The amount of grain at equal to 6 is increasing. On your homework, write a full sentence. Since, as Mr. Manasra, I think. A dash of 6 is greater than 0. Do not freak out. I can give you a table problem and a regular problem. Just merge them. Okay, split up the integral and go. Okay, next, for practice. Okay, independent practice, I'm in no rush. Interpret the problem literally. I want to see, we did it 10 minutes ago. I want to see learning happen. Write something down on your sheet of paper. Do not speak. Do not overthink the problem. It says, what is the average rate at which? Remember, it does not say average rate of change. It just says, what is the average rate at which grain is being loaded onto the trucks? Write something down. Interpret it. Okay, Ms. Ramirez, you want to have a shot?
It's AV
Love you, go on.
1 over A, the integral from 0 to A H T dt.
Which function again?
H of T dt.
Brilliant. Is that easy to do on a calculator?
Yes.
Okay, now stop. Let's talk about units. For an average problem, it's just the unit of that guy. What is the unit for H of T?
Cubic feet per minute.
Minute.
Is that clear? Average questions just have the unit of the function. By the way, before I move on, are at least some of you having a little bit of fun? Like, oh my God, it's exciting to be able to interpret the question. Again, Andelkovic, sweet girl, please keep up to date on your homework. If you don't do today's homework, guys, everybody needs to do today's homework today because I'll be testing these concepts you're learning. Is that clear? Rate in, rate out. If you integrate the rate in, you'll get the amount. Miss Flores, are you getting the hang of it, sweet girl? Miss Flores, are you there? Miss Flores? Okay, Mr. V, how are you doing? Mr. V?
I'm doing good.
You're able to interpret the questions?
For the most part, yeah.
Okay, so interpret the questions literally, please. By the way, your volume is really low. I don't know if you're like 5 miles away. Okay, right on page 22, please. Okay, I'll give you 2 minutes. Sketch that figure. Actually, it should take 30 seconds. Sketch that figure so it's in front of you. Mr. Patel, you're doing okay?
Yeah.
Ms. Valderrama?
Yeah, I'm doing good.
Mr. Saldana?
Yeah, I'm doing okay.
Mr. Smith?
Good.
Okay, please answer the questions exactly the way they're written. Okay, Ms. Flores, are you back? Okay, they're giving us f of 4, and what is the question asking for?
F of -3.
-3.
And this is f dash of x. Okay, write something down on your sheet of paper. I'll ask you, hey, what are you writing? We want f of -3. Do not speak. Okay, Mr. V or Ms. Andelkovic, tell me what to write next step. I need f of -3. Again, Mr. V or Ms. Andelkovic, go.
Equals f of 4 plus integral from 4 to -3 f dash of x dx.
Brilliant. Everybody, this guy, you'll be tempted to write -3 to 4, correct? It's tempting?
Uh-huh.
Okay, be careful, please. What's f of 4 given?
-1.
-1 plus integral from 4 to -3 f dash of x dx. Is that basically the area under the curve?
Mhm.
Yes.
Yes.
Yeah.
Okay, so we need the area from 4 to -3. Okay, we just need the whole thing. Okay, let's find the areas. Okay, drop the perpendicular. Okay, what's the base and height of that triangle?
The base is 1 and the height is 1.
So what's the area of that
1
triangle?
half.
1/2.
Is that in 1/2? Okay, find me the area of the second triangle also. Okay, go.
It's 2.
2.
Is it 2? Is everybody okay then?
Mm-hmm.
Okay, now this is the one that's weird. Should I first make a rectangle?
Yes.
Yes.
So is it basically, I need this area, for those of you who don't get it. Is it basically the rectangle minus the semicircle?
Yes.
Yes.
Okay, just by staring at it, find me the area of the rectangle.
8.
8.
8.
is at base of 4, height of 2.
Yes.
So it's 8 minus parentheses. Okay, let's slow down. What's the formula for area of a semicircle?
Pi r
Pi
s-
squared over 2. Squared over 2.
Or 1/2 pi r square, either way. So it's pi. What's the radius of that semicircle?
4.
2.
2.
So it's pi 2 square over 2. What does that simplify to?
2 pi.
2 pi.
2 pi.
So is that 8 minus 2 pi? Is everybody okay there? So that total is 8 minus 2 pi. Now we've discussed this idea. I'm just showing you. I encourage you to write it maybe with a different pen. So if this whole thing is 8 minus 2 pi, how much is that guy?
4
minus
minus
Pi.
Thank you. Half of that, 4 minus pi. And how much is that guy?
4 minus
4
pi.
Pi.
4 minus pi. Is everybody okay with that idea?
Yes.
Okay, last step. Let's wrap this up. So it's -1 plus. Guys, slow down. We're going from 4 to -3.
Right to
Right
left.
to
Right
left.
to left or left to right?
Right to
Right
left.
Left.
Right to left. So remember we had 8 minus 2 pi. So is that going to be positive 8 minus 2 pi or negative 8 minus 2 pi? Hint, I'm going right to left and below the axis.
8 minus.
Positive 8 minus 2 pi.
So is that just regular 8 minus 2 pi? Is everybody okay there?
Yes.
Plus
Regular 8 minus 2 pi.
1/2.
And then for the 2, is that a positive 2 or a negative 2?
Positive.
Positive 2.
Positive 2 because I'm below the axis.
Minus.
Finally, 1/2
Minus.
Minus.
Half.
because all the signs flip. Everybody okay there? You can combine these like terms. I will not do it, but I'm just showing you. You can combine those like terms, correct? Okay. So everybody follow sign conventions. Right to left means